This video is created only for BK Birla College FYBSc student for education purpose. So student, in last lecture we studied the chlorination of propane and we studied how two different isomers we get. So here now we are going to study the reactivity and selectivity. So these two things are very important for the organic chemist, because when many times we get more than one product, but in that some product are major and some product are minor in yield. So why it is happen, we are going to study now in this video. So already in last lecture we studied that the reactivity of the free radicals. So tertiary free radical is more stable than secondary, and then primary free radical. Primary free radical is highly unstable. And among the halogen, fluorine is more reactive than chlorine. Then chlorine is more reactive than bromine and iodine. Iodine is the least reactive. And the reactivity and selectivity do not get together. It means if your reagents are more reactive, then selectivity get decreased, or vice versa. So in last video we found that when propane we subjected for chlorination, we get two products. One we get in the 45% yield, and another which is formed from the secondary radical is 55% yield. But when that same reaction of propane you carried out in presence of bromine, the amount of the percentage yield of the two product is suddenly get changed. And now see here, propane product is starting material is same, and when you carry out its bromination, so here again in the first step same radical get formed, that is primary radical and secondary radical. So this N-propyl bromide we get in 3% yield, and this isopropyl bromide you get in 97% yield. Same thing in case of bromine. From primary radical we get product in 45% yield, and in from secondary radical we get 55% yield, that is isopropyl chloride. So why this happen? Why if just you change the reagent from chlorine to bromine, percentage change in the product is totally different, and it is only happened due to the less reactivity of bromine. Because chlorine is highly reactive, so it react with primary radical as well as it react with secondary radical in very fast speed. Therefore the selectivity is less. That's why the near about in same percent we get the product. 45% and 55% is not that much difference. But same reaction if you carried out with bromine, then see 3% and 97% means isopropyl we get as a major product here, because your bromine is less reactive. That's why selectively it react with more stable secondary radical, and your bromine radical is also more stable. So more stable species selectively react with each other and give more stable isopropyl bromide as a product in major yield. So thing is that lesser the reactivity of the reagent, greater is the selectivity. And if your reagents are more reactive, then selectivity get decreases. If that same reaction you carried out for 2-methyl pentane, then selectivity is 100%. We get 2-methyl pentane as a only product. And now why it is happen? Why here we not get 2 different or 3 different isomer? Reason is that we get here in this case, tertiary hydrogen atom is get abstract, and what radical is generated from tertiary hydrogen is the tertiary radical. And you know, tertiary free radical is most stable radical. Then your bromine radical is also more stable radical. So this more stable radical react with more stable radical, and product associated with this is 2-bromo 2-methyl butane we get in the 100% yield. Here primary and secondary free radical not form, and if they form, as they are less reactive, and bromine radical is more stable, less reactive, so selectively it react with only tertiary radical, and product associated with the tertiary radical we get as a major product.